Here's our starter for today. We have a simple one-loop circuit. We've got a battery that's lifting the voltage from 0 to 12 volts. And then we have two resistors that are going to split up that voltage and dissipate all that energy into the environment. These could be light bulbs or electric motors or just plain old resistors. So here's how I want you to set this up. Here's what you're supposed to find. I want to know how much current is running through these resistors, what's the voltage drop across each resistor, and how much power is dissipated into the environment by each resistor. Okay. Now, one of the things that we can see right away is that what's going to be true about the current through those resistors? They are going to be what? What is going to be true about this current and this current? They are going to be equal to each other. Why? Because there's only one branch, there's only one path, so there's only one current in this loop. Here's how you figure out the current in a loop. Well, we know that E equals IR. That's Ohm's law. So what I need, though, if this is the voltage, I need, and I'm solving for the current, so the current is equal to the voltage. And you know what? I'll just say delta V equals, and then this is delta V. That the total voltage is equal to the total current times the total resistance. So the current is equal to delta V over R. But this isn't R of these, either one of these resistors. This is R for the total resistance. So how do I get the total resistance for resistors in series? You add them. And be aware that on the final exam, you'll have one like this, but you'll also have one where they're in parallel as well. Well, that's easy to do. This is just 2 ohms plus 4 ohms. Well, not 20 ohms. Two ohms plus 4 ohms. Which is easy to say. That's 6 ohms. And now I can get back to the total current is equal to 12 volts divided by 6 ohms. 12 divided by 6 is 2. And a volt per ohm is an amp. And remember that an ohm is a volt per amp. So if you take volts and divide it by volts per amp, the volts will cancel, and you'll have 1 over amps, reciprocate and multiply, and you get amps. And so both of them will have 2 amps. 2 amps. Well, now we want to know what the voltage drop is for these, and they'll be different because the resistances are different. But now that we know the current, it's easy to figure out the voltage drop. Delta V for resistor number 1 is equal to I1 R1. Well, I1 is 2 amps. And our I2 is also 2 amps. They have the same current. They're in series. And then R1 is 2 ohms. An ohm is a volt per amp. So this is 4 volts. 4 volts. I guess I don't need to put the unit with the number if I put them up here, but oh well. Now R2, V2, I can do it the same way. Four volts per amp, and you'll get 8 volts. But there's another way to get 8 volts if you don't want to go through this, and I know how much work this is. This is just almost unbearable, right, doing all that. But if you know the shortcut, if you know that this is 4 volts, you can figure out that this has to be 8 volts. Why? because it has to add up to 12 volts. Because we had a 12 volt gain, so we need a 12 volt drop. So you get 4 of those volts here, so you have to have, 12 minus 4 is 8 volt drop here. You see that? The voltage man, when voltage man goes on a voltage walk around a circuit, the voltage gains must equal the voltage drops to get back to 0. Get to back to where he started. Yay, voltage man. They should make a movie someday. Now, power. Well, there's 3 different power equations. The main one is power equals current times voltage. Or you can use power equals current squared times R. And, well, I'll use this one. Power equals V squared over R. And it doesn't really matter which one you use. This is like the power that comes out of the battery. We'll talk about that in a minute. But let's use this one. So so P1 is equal to I1 squared times R1. Whoops. Now, by the way, this is going to be multiple choice, so your work, you don't have to show it as in detail as I'm doing, because the problems will be this easy on them. They'll be this easy. So you really don't even need a calculator. I mean, if you do, I'm sorry for you. All right, 2 amps squared times R1 is 4 volts. So what's 2 times 2? 4. What is 4 times 4 times 4 is 16. And that's a watt. Oh, wait, I'm sorry. It's R1. That's stupid. I was getting ahead of myself mentally. What is R1? 2 ohms. I'm sorry. And so that's going to be 2 squared is 4. 4 times 2 is 8. 8 watts. Okay. And then we can do the same thing for P2. It's the same current, but the voltage is 4 ohms. So this is going to be 2 squared times 4 is 16. That's the one that's 16. So what did we say? This P1 was 8 watts, 16 watts. And we're done. Now we can do some things to check to make sure this has to be right. How much power is the battery putting into the circuit? Well, I'll use this one, P equals I times V. That's 2 amps. And what is the voltage gain here? 12 volts. Now, remember that an amp is a coulomb per second, and a volt is a joule per coulomb, so the coulombs will cancel, leaving joules per second, which is watts. And 2 times 12 is 24. So I'm putting 24 joules of energy per second into this circuit. So there has to be 24 joules per second coming out of the circuit. Well, where does energy leave the circuit? Through the resistors. And if I've got 8 watts coming out of this guy, and 12 watts coming out of this guy, I've got 24 watts leaving the circuit. So 24 watts enters the circuit, 24 watts leaves the circuit. The universe makes sense. All is well. So there's a lot of ways of checking your work if you really understand how these circuits work in terms of energy, in terms of voltage, in terms of current. Any questions? That is all.